Imagine trying to track the temperature of a server room every hour. If you use individual variables, writing 100 different lines of code for 100 different readings, your program becomes impossible to manage almost immediately. We're going to solve this in 6 minutes. We will write a C program that collects numbers from a user, stores them in an array, and then passes that entire set to a function to calculate the total sum. To follow along, open up your preferred C compiler or an online IDE. Moving from individual variables to arrays allows you to handle growing datasets without rewriting your code for every new piece of information you receive. An array is a fixed-size collection of similar data. Instead of being scattered across your RAM, these items are stored in contiguous, back-to-back memory locations. Visualize this as a row of blocks. Each holds stored data, like these numbers 2 through 18. The numbers beneath represent specific locations. Pay attention to the numbering. Array indexing strictly starts at 0, so the final indexed is its total size minus 1. In your IDE, declare the array by typing float num, then inside square brackets, the number 6, followed by a semicolon. This line of code tells the compiler to set aside a block of memory specifically for 6 floating point numbers the moment the program compiles. Because this memory is strictly defined, trying to access an index that doesn't exist, like -1 or 6, will result in the program pulling back nonsense data from outside the array's boundaries. Now that we've mapped out the exact memory boundaries, we have a safe structure ready to hold our data. Now we need to populate that structure. Instead of hard-coding values, we'll set up the program to capture input from the user while it's running. Inside your main function, light a for loop. Set the counter to 0, running while less than 6. Inside the loop, use scanf with the %f format specifier. Using the ampersand nome at index I tells the computer to save input at the memory address of each index. To make sure it's working, you can add a temporary printf loop afterward to print the numbers back to the screen and verify the data was captured. Here is a common mistake. If you have a second array, you cannot simply set it equal to the first one to copy the data. To copy an array in C, you must use a loop to move the information one element at a time to the second set. Our array is now completely full of live data, but we still need a secure way to process it. Clear out your verification loop. We will set up a separate function to handle the math. In your main function, call a new function by writing float result equals calculate sum num. Then add a final printf to display the result. Now move above the main function block. We need to define exactly how calculate sum works. Write float calculate sum, and inside the parentheses add float num followed by empty square brackets. This tells C the function will receive an array. Inside this function, use another for loop to step through the array. With each pass, add the value of the current index to a running total variable. By doing this, you've kept your code modular. The logic for calculating a sum is now separate from the code that collects the data. Now compile your code and execute the program to see the result of your work. The terminal will wait for your input. Enter our 6 test numbers, 23.4, 55, 22.6, 3, 40.5, and 18. Hit enter. The function processes the array and returns the final sum, 162.50. Because arrays require very little overhead, this simple logic is the same starting point used for complex tasks like sorting lists or searching for prime numbers. You've now moved beyond basic variables. You have a reliable way to organize and process groups of data as a single, manageable unit.